Today we're going to talk about something called the law of sines. The law of sines allows us to solve for sides and angles in triangles that are not right triangles. So far in all of our study of trig, we've been working with right triangles. And in a right triangle, we can use SOHCAHTOA. A right triangle has a hypotenuse, and so that allows us to do opposite, adjacent, and hypotenuse. But what about if we have a triangle that looks something like this? If there's no right angle, there's no hypotenuse, and so SOHCAHTOA will not work for us. So what we're going to do instead is I'm going to label the angles capital A, B, and C, and then as a convention, we label the sides opposite of each of those with its lowercase name. So across from the capital A, I call that side little a. I could also call it side BC by naming its two endpoints. That means the same thing. So we could call this part over here, we can either call it little a or we call it BC. It means the same thing. Then across from the B, we would call that side little b, or we call it big AC. And then across from angle C, we call that side little c, or we could call it big AB. Okay? So that's how we can name those sides. And what we're going to do is use the law of sines to find missing sides or angles in here. Our law of sines is sine of A, big A, over little a, because trig, whether it's sines, cosines, or tangents, or their reciprocal functions, trig is always applied to an angle. So sine of the angle over the side. A trig function is always applied to an angle. So sine of angle over side. And we're going to set that up as equal to using letter B, which is also equal to using letter C. And that will allow us to find missing sides or angles in a right triangle. So let's look at an example. A, B, C. I'm going to fill this one in as 45. I'm going to fill this one in as 30. And I'm going to say that in this problem, we want to solve for AB. Okay, solve for AB, which is also known as little c. So that's what we want to find, is that side. Oh, you know what? We need more information here. You always need 3 pieces of information, and I didn't give any other piece of information. We'll throw that a 7 on there. Sure. Okay, so now that that's labeled with a side, now we have enough information. You always need 3 pieces of information. Okay, so to use the law of sines, notice that in those fractions, each fraction is set up with a matching letter, an angle and a side that matches. So what that means is we have to have that information. We have to have matching angles and sides. So if I want to know what little c is, that means I really actually have to know what big C is. There's a rule about the angles of a triangle, which I'm sure you've learned before at some point in a math class, but we haven't talked about it in this class, I don't think, really. And that's that the angles of a triangle have to add up to 180. So angle A plus angle B plus angle C has to equal 180 degrees. Always 180 degrees in a triangle. So if I take 180 and I subtract from it the 45 and the 30, that leaves 105 degrees left over for angle C. If I want to find what little c is, I have to know what its partner is. I have to know what that piece across from it is. Okay, so now what we want to do is find those pieces that are across from each other, and that's what we're going to use to set up our fraction. So C is one of those pieces that's across from each other that I know. The other one is I know 7, which is across from A. So 7 is little a. And those are what we're going to need then. That 30 on B, it's actually just extra information right now. we needed it because we needed to figure out the 105, so we had to use it, but we're not going to use it anymore. So now I'm going to set up a fraction with the a's, sine of 45 over 7, sine of the angle over the side, and I'm going to say that's equal to a fraction for the c's. Sorry, sine of 105 over little c. Only one piece of missing information, so that means that this is solvable with algebra. If you have more than one piece of missing information, you can't solve it with algebra. So to solve this with algebra, this is what we call a proportion, a fraction equal to a fraction, and we solve that by cross multiplying. So I'm going to multiply across this fraction. My screen froze. See if it catches up. Oh, no, it just disconnected. Loading, back. Okay, I think we're back in business. Sorry about that, little delay there. Go grab some popcorn. Okay, so now that we're back at it, we're going to solve this by cross multiplying. C sine of 45 equals 7 sine of 105. And I do suggest that you put that 7 out front, excuse me, because we're not multiplying 105 times 7. We're multiplying the sine of 105 times 7. But what we want to know is what is c, and c is not alone yet, so we're going to finish out by dividing by that sine of 45. Now we have quite a bit of messiness here, but you can actually type it into your calculator just as it is. One thing to make sure of, when you press a trig button on your calculator like sine, it automatically opens up some parentheses. Make sure you close those right after that number. Don't wait until the end of the problem to close them out. Close them out right after that number, and same thing with that 45. So I'm going to type into my calculator, got my calculator right here, 7 sine of 105. I'm going to close those parentheses, and I'm going to divide by the sine of 45 and closing out those parentheses, and I get 9.56. 9.56 is what my calculator tells me that this is equal to. Pay attention on Khan Academy for whether they want you to round to hundredths or tenths, how many decimal places you need to include there, okay? All right, so that's solving for a side. We can also use this to solve for an angle. I'm going to go ahead and erase this problem. I'm going to leave the law of sine stuff up at the top there, but I'm going to erase this problem so you can always pause your videos or rewind. That's one of the nice things, I guess, about watching at home instead of in class, is if I start to erase and you're like, oh, no, wait. But at home, you can just rewind. All right, so in our next problem, we're going to look at solving for an angle. So let's see, A, B, C, 96, 17, 19, solve for A, and then it's going to say something like, note A is acute. Okay. So a little bit of a geometry vocab reminder for you. Again, a word that I'm sure you've learned before. Acute means smaller than 90. A 90-degree angle is a right angle. Acute is cute because it's so tiny. It's smaller than 90, so it's, oh, cute, acute. So we should expect an answer that's smaller than 90 as our answer. All right, so we have to find our partnerships. So remember, we need to look for across from each other makes a partner. So there's one partner, 96 and 19 across from each other. That's good. And our other one, well, I want to know what angle A is. That's our question. And across from that, we have that 17. So we're ready to go then. It doesn't tell us what angle B is or side B, but we just actually don't even care because we have enough information with those other two fractions. So we're going to say sine of 96 over 19, and that's going to be equal to the sine of A over 17. Angle A is what is unknown. Okay, you can solve this as a proportion and cross multiply, and that will totally work. It's a little bit faster if instead we just multiply both sides by 17. Okay, if you chose to cross multiply on this, what would happen is you're going to get 17 sine 96 equals 19 sine A, and then you would have to divide by 19, and you end up right where I already am on the other one. So it takes one extra step. So a little bit faster to just multiply by the 17, but not much, just saves one step. Okay, so now I'm going to type into my calculator this 17 sine 96, but remember, open and close parentheses. So 17 sine, it automatically opens. I type 96, I close them, and divide it by 19. Now that gives me an answer of, when I type all of that into my calculator, I get an answer of 0.889835. That seems like a really small angle. I'm trying to find angle A, and that's tiny, right? That's because that's not my answer yet. If you look at what's left on this side, that's equal to the sine of A. So then we have to remember from a previous lesson, how do we undo those trig functions to figure out what A is? Our undo is the inverse trig function. So I'm going to inverse sine both sides. Inverse sine cancels sine, just like putting on socks and taking them back off. So then I'll find out what A is when I take the inverse sine. Now, I wrote out several decimal places, and I suggest that you do type into your calculator several decimal places. Otherwise, if you round too much, it's going to create error. And then when you go to type in your answer, it's going to tell you like you're close, but you're not right. And that's because that error built into it. So I got 62.85. I believe Khan Academy usually wants you to go to the nearest degree. So we're going to say 63 degrees, which is smaller than 90. So that's good. That answer makes sense. And that is our answer for this question. Okay. We're going to do one more example, solving for an angle. So one more that is like this one, but has an extra twist. Okay. In this one, I'm going to say A, B, C, 14, 12, 57. We're going to say solve for B. Note, B is obtuse. Okay, obtuse as a geometry word is bigger than 90. So 90-degree right angle, acute, where those small ones are so cute. Obtuse, bigger than 90. So we should expect to get an answer bigger than 90 in this problem. Okay, so let's set up our work. We got to find our pairs. So here's one pair right there. Those are across from each other, so that's good. Those are opposites. That's what we need, opposites for this. And then we're supposed to find angle B, and there we go. B is across from the 14, so we got what we need. So I'm going to go ahead and set up my fractions. I got sine of 57 over 12, and sine of B over 14. Okay, so I can cross multiply, and that will totally work. Or because B's on top, I can just multiply by 14. A little bit quicker, just one step quicker. I'm going to type this into my calculator, remembering the open and close of parentheses. So 14 sine 57, close those parentheses, divide by 12, and I get my long decimal answer of 0.9784489, blah, 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 right? And that is equal to what's left over here, which is the sine of b. So not my answer yet. I need to undo sine with an inverse sign. Undo sine with inverse sign, that leaves me with just the b. Inverse sign, typing in a whole lot of those decimal places, and I get 78. 78 is angle B. B is obtuse. So here's the thing about inverse sine on your calculator. When you do inverse sine, your calculator is programmed to only give you answers that are acute. So how do we find the matching answer that is obtuse? They are what we call in geometry complements of each other. Or sorry, supplements. I teach geometry and I just said the wrong word. They're in geometry what we call supplements of each other, which means the angle that this problem actually just found was this angle out here that makes a straight line. It actually found for us this angle is 78. So if I want to find the other side of that, what we need to remember is that a straight line makes 180 degrees. So I have one extra step that I need to do because this guy is supposed to be bigger than 90. I'm going to do 180 minus the answer that I just got, 78. And if I do 180 minus 78, that gives me an answer of 102. And that is actually the answer that this problem is going for. And you might be like, why? Why could that possibly? It already gave me that. Well, let's try to go back to trying to figure out how to let you know which step I'm talking about. This step right here, I'll highlight, where it said that the sine of b was equal to 0.978, blah, blah, blah. Well, if I type into my calculator the sine of 102, which is what I am now claiming the answer is, if I type in the sine of 102, my calculator says 0.978147. Well, that's really close to the same thing it was before, right? 0.978, and then it's a 4 or 1. Well, there's some rounding error involved because it wasn't exactly 78, it's not exactly 102, but it's really close. So the thing is, there's multiple angles that give the same answer for sine. So on a problem that says obtuse, we have this one extra step to do at the end where you're going to want to do 180 minus what your calculator told you, and that will give you the obtuse answer. This stuff is kind of tricky, so please ask me your questions, email me, and I will explain as good as I can over email, or if it's easier, we can just go into a Google Meet and I can explain to you that way. But please don't feel like you have to struggle through this alone. Ask me your questions. I am happy to help. Okay, talk to you soon.